Hi everyone and welcome to part 2 of the third-person shooter tutorial. Last week we saw how to import animation, how to bring them into Godot, and how to build a state machine so we can drive the animation. Now this week I want to start assembling the structure for our camera, because third-person shooters camera are a pretty important part of the whole thing. There's gonna be a little bit more chatting in this episode because I don't want to just show you how to do it. I want to try to explain to you the reasoning behind what I'm doing and why I'm doing it and how I'm doing it. For example, last week we did the whole downloading animation and importing animation where we could have done it much more easily with just creating a bean and moving him in the code. And that would be totally fine if you're working on a prototype or if all you want to do is learn a little bit of the basics of game development. But if you're really planning to make an actual game, you're definitely going to need to know how to handle animations, transitions, blending of animations, and all of this kind of stuff. So I think it's a good idea to show you how it's done properly, if you will. And it's something very similar for the camera. There's some very simple stuff you can do to set up a basic camera system with just the nodes that Godot provides you. There's a bunch of nodes that will do most of the work for you. But I think it's a problem in a more complex game where you're going to have very different situations. For example, if you put the camera inside the player, well, what happened when you don't have a player? Maybe you have a cutscene without the player in it, or maybe the player is actually the same model as the AI. So what happened? Do you have a camera for each AI in your scene? Or do you have the camera outside of the character? But if it's outside the character, then you need to use some kind of remote transform to track the player position or something. I think in the end, the camera is just a simple transform, a 4x4 matrix with a rotation and a translation. So why not create your own structure and in script code everything you need of your camera, including stuff like smoothing, transition, and potentially animation. So that's what I'm going to try to do today. So to do this, we're going to go back into the project we had last week. So if you remember, in the main scene, we added this camera right now that's totally fixed just to look at the player from our main scene. So what we're going to do is I'm going to create two scripts for driving this camera. The first one is going to be the camera script itself. That's going to set the camera position and rotation. And in this camera script, I'm going to have a couple of different things, but the first thing I want to add is an export nodepath on ready var target that's going to tell the camera what we want it to follow. And I just learned that you can do all of this in one single line, which is pretty cool. And if we select the camera now, we can assign it the player as our target. Now, the other script I want to create, we're going to have to create it here because I want to create a resource script. So we're going to make it inherit from resource. And aside from that, it's going to be pretty much the same, and we're going to call this camera data. And if we open it, as you can see, it extends from resource. And what that's going to do is that it's going to allow me to create a custom resource with a bunch of data inside, because Godot doesn't really have traditional structures, and classes cannot be really well indented inside other classes. So what I want is a structure that I can use inside my camera to set up a couple of different parameters for the camera. And this is a structure I've come up after a couple of years working with third-person shooter in my games and stuff. And it's served me pretty well. It covers most of the bases, and it's based on my personal perception of what I imagine a movie camera to be. I'm thinking of, like, if you look at the behind-the-scenes videos of famous movies or stuff, you're going to see stuff like this boom crane that's, like, hooked to a car on the pole, and then there's the camera here on the gimbal. And that's kind of what I want to recreate, because by having these parts as data, then it's going to be very easy for me to add effects that you would find normally in real life. So another example is something hooked to a car like this, or something on wheels like this with a long arm and the camera at the end. And to do this, I'm going to have to create a couple of different variables, and I'm going to export all of them so that later when I add this camera data inside my camera script, I'll be able to tweak them on the fly while the game is running. So the first one I'm going to do is, of course, going to be the target offset. Now, the target offset is going to be the length of the pole. So basically, if the character is facing in the Z positive, then moving the camera back in the Z negative is going to put the camera behind the character. But I could also move it a little bit on the right or the left or something like that. So that's why it's a vector 3 instead of just a length. Now, the next important part is going to be the rotation of the pole around the target. And now this one you have to be a little bit careful because it can create some issues. So basically you have to picture it as the yaw around the character and then the pitch to move up and down the character. But there's also the roll, but most of the time you're not interested in having any roll. And there's a problem that arises when you reach the top of the pitch, because then the camera is kind of perpendicular to the ground and you don't know where you're looking anymore, so you start rolling like crazy. So the easiest way to avoid this kind of problem is actually just to have a limit on how much pitch the player can do. Anyway, you rarely want the character to be able to see under the shoes of the character, so the best way to do it is just to have a vector 2 that's going to be the pitch limit. Now with this, we already have a pretty good setup, but I like to add a couple more settings that will really allow you to do anything you want. The first one is going to be another vector 3 that I'm going to call anchor offset. This is going to basically move the origin of the pole that we set up before somewhere on the target that you want to follow. Because if you look at the pictures from before, like, see this here, the pole is mounted on the door of the car, but usually when you export a model, for example a character, the origin of this character is going to be on his feet, and you don't always want to move the camera or the pole relative to the feet. Sometimes you want something more like the shoulders or something like that. So the best way to do this is to have this pole offset or this anchor offset. And finally, the last property I'm going to add is another vector 3 that I'm going to call the look target. Because again, usually the camera at the end of the pole will be mounted on some sort of gimbal. So if you look here, you can see this gimbal really clearly. And this allows the camera to move independent of the car or the pole itself. And this allows you, for example, to have the camera positioned a little bit to the left of the character, but looking slightly to the right. Not necessarily straight in line with the pole that's hooked to the character, or not necessarily always straight forward. Now, this could be another rotation, actually, but in my experience, it's a little bit easier to think about it as just a point you want the camera to look at. Now, once I have this, I can go back into the camera script and then I can add another export resource and I can have this setup that's going to be the camera. Now, I haven't found a way to tell Godot that I want this resource to be a camera data, but that's fine. I can go in the camera data, give it a class name, and in the camera setup here, I can go and select the camera data from the list. It's just a little bit painful. I wish it was by default the camera data. And when you click on it, then you're going to see all the properties we added. So we can put the pitch limit, for example, -45 to +80 or something. And now that we have that, we can go into the camera script and start converting this camera data into an actual camera position. I could create a tool script that would allow me to place the camera in the editor using these properties, that would actually be the best. So I could just like click on the camera, click preview, and then fiddle with these properties. And if I have a tool script, I could update these properties and the position of the camera on the fly. But that's a little bit much maybe for this tutorial. So what I'm going to do instead is in the ready method, I'm going to take whatever position I put the camera and assume that this is the camera offset I want for my character. And what we're going to do is if the target offset is 0 and we never want the offset to be inside the character, we'll just assume that it's not set, and we're going to use the origin of the camera and the target as the actual offset we want for our character, without forgetting to remove also the anchor offset that we added before, which could be 0. In this case, the pole is just going to be at the origin. And I'm going to do something similar for the look target. If it's set to 0, I'm going to assume we just want the camera to look straight ahead, giving it some kind of random value straight in front of it. I'm also going to set up the pitch limit as radian instead of degrees. It's just that for me, in the settings, it's easier to use degrees, but for the game, it's easier to use radian. So we're going to convert them into radian. Maybe, ideally, I should store this in a different variable so I don't overwrite data from the resource file, but yeah, for now, that's going to do. And now we can start moving the camera every frame. So we're going to do this in the process. Now, one thing that I've found very important when dealing with camera is that you want to layer the effects you apply on the camera. You want to try to do it one by one. So this way you can easily go back one step to figure out what's happening with your camera if something's not going right. So in our case, the first step is going to actually be every frame positioning the camera origin to the target's transform dot origin plus the anchor offset we set before. So this is going to put our camera straight on the character, like on its head or on its shoulder or whatever we want, where we want to hook the camera to the character. Then we're going to declare a couple of variables, because we're going to be transforming these variables every frame based on the character rotation and position, or the camera rotation and position. And for the pitch and the yaw of the camera around the character, we want to make sure that we're moving the pole of the camera in yaw first, and then pitching relative to where the camera is at that moment. And to do this, actually, we're going to figure out what's our axis for the pitch by taking the default right vector and rotating it by the yaw of our camera. So our target offset that we took from the setup is going to be rotated in yaw by whatever we set in the camera setup. And also the look at that I mentioned before is local to the camera rotation. So I'm going to do the same thing to the look at from the camera setup. I'm going to apply the same rotation. And now that we've applied the yaw, we can apply the pitch. So I'm going to apply the pitch. And I'm going to do the same thing to the look at, just like I did for the yaw. I'm going to do the same thing for the pitch. Now that we've positioned our camera the way we want it, we can just pull back and set it at the end of its pole by doing self.transform.origin plus equal target offset that we've rotated around the character. And to set the gimbal on the camera at the end of the pole, we can just use a simple look at It's a very useful method in Godot to set a rotation. Like you see, we're passing the up vector that's going to set the roll. In our case, since we limit the camera, we never have to really deal with a different up vector. But in certain cases, it could happen. One thing that happened to me before is I was making a flight simulator and you could do barrel rolls. So when you do a barrel roll or a half barrel roll, then the airplane would be upside down and we wanted the camera to follow. In this case, I had to be really careful about when and where and how I was flipping the roll and turning the camera on itself. But outside of these extreme cases, you should never have to deal with the roll. And you can just use the up vector, the Y vector, as the up for your camera. Now we can go back in our 3D scene, and if we move the camera a little bit, click the preview button maybe, we can set like the way we want the camera to be looking. Maybe a little bit closer, a little bit to the left. And then when we hit the play button, then the camera should be following the player. So we have the basic camera structure working, and I still don't want to get into the control schemes just yet, but it'd be nice to see our camera rotating around the player. So let's just go back into our camera and add an unhandled input event. And we're going to do a little bit of magic to rotate the camera around the player. It should be very simple because we already have the whole structure. It's just a question of handling the input touch. And I'm going to be using the input touch emulator by doing event is input event screen touch. And the reason I'm doing that is because this way it's going to work even on mobile. Of course, if you're only interested on PC, you can do mouse click or mouse touch or stuff like that. But in my case, I'm going to be using the touch emulator so that everything works on mobile too. But for it to work, I have to keep a couple of variables. I'm going to have to remember when a touch is pressed. And I'm going to have to remember the position of the last touch. So when a new touch is detected, I'm going to make sure that if someone wasn't already pushing, because on mobile you can have multiple touch, so I'm going to set pressed to true, and I'm going to remember the last position. So I'm going to basically be initializing the position when you detect the first touch. Now, if the event is an input event screen touch and the event is released, then I can set my press to false. Then, if the event is an input event screen drag, and my pressed is initialized, then I can add the drag from the last frame to the rotation of the camera. And we're going to do this by calculating the difference between the last position of the touch and the new current position. Of course, this is going to make the camera move way too fast, so for now, I'm just going to divide by a certain number. It's up to you to choose it. You could even expose it so that you can tweak it on the fly. And I'm going to add this rotation to the setup that we created before, that, if you remember, we're already using in the update to calculate the position of the camera. One thing you'll notice is that we can use here the pitch limit we set up in the camera data to make sure that the camera never pitch above its limit. And of course, we have to remember the position for the next frame. We can test that everything is working, and oh my god, there's something wrong with the camera. Thankfully, it's just a typo. It's because I copy and pasted a bit too much. So now everything should be working fine. So as you can see, now I'm looking up and down and I can turn around the character, and then when I'm moving, the camera is following. And just what I was mentioning is now I can go, for example, in the camera setting, I can look at the resource. And if I want to, I can set up a bunch of parameters. So the point being that if I set the target offset to 0, as you can see, we're on the feet of the character. And that's not really what we want. Even if I pull back a little bit, you'll notice that we're pretty low here. The best solution to this, like I was saying, is to have this anchor offset so that I can raise. And you'll see the difference. If I put it at 0 here, now our pole is going to be set up at the feet of the character. And I can, of course, raise the camera so that you have to imagine that the pole is going from the feet of the character to the top of its head. And it seems to be working pretty well, but as you can see, when I'm rotating here, like the head is moving a lot because we're actually rotating from the feet. It's even more obvious if I get closer to the character. So now I'm over his shoulder, but when I'm rotating, whoa, he disappears from the screen because I'm moving from his feet. And the solution to that is to move the anchor offset like I was mentioning. So if we go back and to his feet and we raise the offset of the anchor and maybe a little bit up and maybe a little bit to the right, now I'm rotating on his shoulder, and so his head is basically always in the same position no matter where I'm looking. And that's what the anchor offset is used for. And like I was saying, using the look target, even though the camera is hooked to the shoulder of the character, it's easy to make the camera look a little bit more, for example, to the right or to the left. But still, we're hooked to the character's shoulder, so we're kind of looking, a little bit on the left of the character all the time. And that's what these parameters are used for. And of course, the limit is working. As you can see, we can't go past a certain amount and we can only see the top of his head, but we don't flip around. If, for example, I was to set a limit to like 180 or something, then I would be able to go above and then weird stuff starts happening. So yes, we still can't quite move the character, but the reason for this is because in third-person shooters, the movement of the character is very dependent on the position of the camera, but also the position of the character and the keys you're pressing. So all of this needs to kind of be set up a little bit so that you can actually implement proper character controls. So that's what we're going to be talking about in the next episode. So until then, see you all. Bye!